Hello guys, welcome to Pepcoding, and now I'm going to discuss the next question, that is the diameter of a binary tree all method. Okay, so we have already done this question in our level 1 video, and now I'm going to discuss all the possible methods of a diameter of a binary tree. Okay, so let's see what is actually the diameter of a binary tree. Okay, so what is the diameter? So diameter is the largest distance between two leaf node. Okay, so the largest distance between two leaf node is the diameter of a binary tree. Okay, so this is what the diameter is. So let's see the example. So for this tree, the largest diameter is equal to the for this tree, the largest diameter is equal to the 1, 2, 3, 4, 5, 6, 7. Okay, so the largest diameter is 7. Okay, so let's try some another path that are possible. So these two, let's see for these two leaves. Okay, so the diameter is 1, 2, 3, 4, 5. The diameter is only 5. So we have to find the largest diameter, that is 7. Okay, let's see some another path, that is 1, 2, 3, 4, 5, 6. Okay, so 7 is actually the maximum. So that in that case, what is the largest diameter? Largest diameter is equal to 7. Okay, so you might be thinking that the largest diameter is only possible by using the root node, but it is not always possible. Okay, it can be possible, but it is not always true. So let's take some example by which I can show you like it is not possible always. 14, 15, 16, 17. Let's take 18 and 19. Now let's calculate the diameter now. Okay, so in that case, if I calculate the diameter 1, 2, 3, 4, 5, 6, 7, 8, 9. So the diameter is 9 for the root node. Let's try for this node. Okay, let's try for this node. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Now the diameter is 11. So it can be possible like the diameter does not pass with the root node. Okay, so there is possibility. Now how can we do this? So we have already done the method by calculating the height. Okay, so we already know this method, and I'm going to do that method first. I'm going to discuss that method first. After that, I'm going to discuss the new method by using the heap memory. Okay, so how can we calculate our diameter? So actually, let me calculate the diameter for my node. Okay, so how can we calculate the diameter? So my diameter is, so if we have to calculate the diameter, we have to find the height. Okay, so how can we calculate my diameter? Suppose I have to calculate my diameter. So my dia. Okay, so how can we calculate this? So we have to calculate the height of the left node and the height of the right node. Okay, so we have to calculate the height of these two nodes. So first I'm going to calculate the left height plus right height. Okay, plus right height. So first I'm going to calculate the height for this node and this node, and I'm going to add this. Now we already know the length, the height of these two nodes, and in the end, what we have to do, we have to add these two nodes also, that is plus 2. So this is how we calculate my diameter. Okay, so we have already discussed in level 1. So I have just given the brief introduction for it. Right height plus 2. Okay, now what is the maximum diameter for this tree? So how we calculate this? How to calculate maximum diameter for this tree? Okay, so for this tree, how we calculate this? So as I have already discussed that it can be possible that our diameter lies in some other node, that is in some other child node. Okay, it is possible. So what we have to do is first we have to calculate three things. Okay, so for calculating the diameter, we have to calculate the three things. The first thing is we have to calculate the left diameter. First we have to calculate the diameter of the left side. Okay, so left diameter. Second, we have to calculate the right diameter. Right diameter. So, actually, what we are going to do is we are going to use the faith call. Okay, so it is just the abstraction. Okay, first I'm going to calculate the left diameter, then I'm going to calculate right diameter, and in the end I'm going to calculate the my diameter. My diameter, and then I'm going to take the maximum of all these three. Suppose we already have the maximum diameter to the left side, so final diameter will be the left diameter. Okay, so I'm going to calculate these three things, and then in the end I'm going to take the maximum of all these three. So let's code this first. So we have already coded this, so I'm going to do it very quickly. So first what we were doing is we were calculating the height, void int height. Okay, so for height I'm going to pass the tree node root, and if root is equal to null, then we have to return -1. And first I'm going to use the left call, that is int left height. So I have to take the maximum, return math dot max of left height. What is the left height? Height root dot left, and then I'm going to calculate the right height. For this I'm going to do the full screen first. Okay, so I'm going to calculate the right height, and then I have taken the maximum, and then in the end I'm going to add +1. So we already know this code. So first we are going to calculate the left height and right height, then we just take the maximum of it, and in the end I'm going to add the +1. Okay, so this we already know. How to calculate the diameter? See, for this, for calculating the diameter, first we have to calculate the left diameter. So for this I'm going to use the base condition, that is the root is equal to null, then we have to return 0. And first I'm going to calculate the left diameter. Left diameter is equal to the diameter of a binary tree, so root dot left, and right diameter, that is root dot right, and then in the end I'm going to calculate my diameter also. My dia. For my dia, what we have to do is we have to calculate the left height. So left height, that is calculated by the height function, root dot left, and then root dot right, and then calculated the my dia. My dia is left height plus right height plus. So this is how we calculate the my dia. Then in the end we just simply take the maximum of all these three. Math dot max of left diameter, right diameter, and the third one is my dia. So we already know this piece of code. So just simply run this and check for the compile time errors. So there is a compile time error, we void int height. So I have initialized static. Now let's run this. So there is one more compile time error, int my dia plus you cannot find the symbol RH, that is right height. Now run again. So it is accepting. So we have already know this piece of code. So first I'm going to analyze it, what actually problem in this code. Okay, So let me take this first. Okay, so now I'm going to do the dry running. First, I'm going to shift this. Okay, so this is actually of our code. So see, the problem in this code is, see, when you are in a root node, okay, so then just you call for the left side for the diameter. Again, you call for the left side for the diameter. Again, when you call for the left side, that is you got the null value. Let me just decrease the size so that we can do save our time. So now what we are going to return is, it is returning 0. Actually, we don't have to return 0. Yeah, it's correct. Okay, so we have returned 2 null. So what is going to return? Diameter is 0. Okay, then again it is going to for the right call, so it is also going to return 0 over here. Okay, so both the side it is going to return 0 and 0. Okay, now we have to calculate the diameter of this node. So what will be the diameter? So first it is going to calculate the left height, that will be the -1, and the right height, that will also equal to the -1. And what is the diameter? -1 plus -1 plus 2, that is equal to the 1 is 0. Okay, so that will equal to the 0. So now the my diameter is will be calculated 0. Okay, then what is going to happen? Then we have calculated the left diameter for the node 2. Okay, so we have completed this call. Now we have to calculate for the right call. Okay, so now the code is going to be here in this position. Now what is going to happen? Again, it is going to calculate the left and right diameter. Okay, so first it is going for the left side. So again it is going to return 0 over here, because we have already seen how the diameter is being calculated for the leaf node. Okay, then it is going for the right side. So again it is going to calculate 0 over here. Okay, so the diameter will be equal to 0 over here. Now, so we have already calculated these two things for the fifth node. Okay, so now we have to calculate for the 5. Let me take for a 5. Suppose this we are calculating for 5. We have already calculated these two calls for the node 5. Now what we are going to do, we have to calculate the diameter of this node. Okay, what will be the diameter? Again, I'm going to call these two things, that is the height as well as the uh, I'm going to calculate the left height as well as right height. So what is going to be the left height as well as right height, that is equal to the 0 and 0. So diameter is equal to the 0 plus 0 plus 2, that is equal to 2. This is what we have to return from there. Okay, because the maximum of all these three will be my dia only. Okay, because left diameter and right diameter are equal to 0. Okay, so in this case our diameter is equal to 2, and then we have returned it. So from here we have returned my diameter, that is equal to 0, and from in this position we have returned the my diameter, that from 2. Okay, so now we are calculating for the second node. Okay, so now we are calculating for the second node. So what is value of from the LD, that is the left diameter is equal to 0 and RD is equal to 2. Okay, so we are calculating for the second node. Okay, now we are calculating the my diameter for second node. So how we are going to calculate my dia? So the left height is equal to 0. In this case, going to return 0, and for the right side it is going to return 1. Okay, for the right side is going to return 1. For the diameter of the height of 5 is 8, and for this we have to calculate the height from using this function. We have already created this. Okay, so again we are just using these two call. We are calculating these two things for each node. Okay, so now you can see how much time is actually we are wasting. Okay, So the left height is equal to 0 and the right height is equal to the 1. Now we are calculating the my diameter for this. So how can we do this? Left height is 0 plus 1 plus 2. Okay, so what is actually the my diameter? My dia is equal to 3. Okay, now we have to take the maximum of all these three, that is 0, 2 and 3. And what is the maximum of all these three? Is actually 3. So we are going to return 3 over here. Okay, so we are going to return 3 over here. So what is the diameter for this node? The diameter for this node is, the maximum diameter is equal to 3. Okay, so now what is going to happen? Suppose this is for one node. So we have already calculated the left diameter. Okay, so we have calculated the left diameter, that is equal to 1. Now I am going to calculate the right diameter. Suppose we have calculated all the diameter like by using this process only. Okay, so uh, it is going to calculate the right diameter, that will come 1 only. Okay, so for this we will calculate the right diameter, that will come 1 only. Okay, not 1, actually 2. For this node, the right diameter is equal to 2, because you can see from here. Okay, right diameter is equal to 2. Now for one node, we have calculated the left diameter as well as the right diameter. So what is the left diameter? Left diameter actually equal to 3, right diameter is actually equal to 2. Now I'm going to calculate my dia, that is equal to 2 plus, sorry, left height. So for this, we have to calculate the left height as well as right height. So what is the left height? Left height is equal to 2 and right height is equal to 1. So we already know how to calculate this because we have already created this function. So now you can figure out what is the problem with this code. So again and again for each node, I'm going to calculate the height, and height is actually big of n complexity. Okay, so for each node, it is going to take this time. Okay, so we have to save this time, so it is going to calculate height each and every time for each node. Okay, so now again I'm going to calculate the diameter, that is 2 plus 1 plus 2. Okay, so what is the diameter? Diameter is equal to 5, and we have to take the maximum of all these 3, 3, 2 and 5, and it is equal to 5. So the diameter is equal to 5 only. 1, 2, 3, 4, 5. Okay, this is how we just calculate the my diameter, but this is actually not an efficient way, because we are calculating the height, left height as well as right height in for each node. So we have to do something else, okay, so that we can just save our time. Okay, so how can we do this? So we have used, in this time we have used a like we are calculating the height, but what I'm going to do right now, I'm going to use the heap memory. Heap memory, we already know what is heap memory. Okay, so by using the heap memory we can save the time. So for each node I'm going to store the height as well as diameter. Okay, so like suppose I am in this node, so I will already calculate the height. I'm going to calculate the height and diameter. Okay, so I'm going to store these two things. Okay, so I'm going to store these two things for each node, and for this we have to take our heap memory, and we can take whether the pair class, or we can also do it by using the array, the concept of the array. So for this we have to we can do it by using class, that is my pair, or I can do by using the array. Okay, so by using any of these two methods we can calculate this. So for this I'm going to use the array. Okay, so let me do this, and then we are going to discuss it. Okay, and what I'm going to store, I'm going to store in 0th index, I'm going to store diameter, and for 1th index I'm going to store the height of that node, of that particular node, as well as the maximum diameter of that particular node. Okay, let's see this. So for this I'm going to remove this function. Okay, and I'm going to return the array. Okay, so I'm going to return this array for each node. So let me take one more method, public static int, and let's calculate dia as well as height for each node. Okay, so let's calculate this. So first I'm going to pass two things, that is the root node and take the variable node. Okay, so for this, how can we do this? I'm going to remove this. So how can we calculate this? I'm going to handle the base condition, that is if node is equal to null, that means we are in the leaf position. Then what we have to return? We have to return the new array, that is I'm going to return the new int I'm going to return the new array new int. Okay, so for what will be the dia and height of the leaf node, not a leaf node, for a null node. Okay, suppose when a node is equal to null, so what will be the base condition? So first I'm going to store array like this. First I'm going to store the diameter, then I'm going to store the height. Okay, so the diameter is equal to 0 and the height is equal to -1. This is for the base condition. Okay, now what I'm going to do is I'm going to find the left data, that is the left maximum diameter. Let me write some other way. So I'm going to calculate the left data as well as the right data. And what is stored in the left data? The diameter of node 2. Okay, and the height of node 2. Okay, suppose this is an individual question. So in this node, what I'm going to store is I'm going to store the diameter up to this tree and the height up to this tree. Okay, and same thing I'm going to store for the diameter of 3 and the height of 3. Okay, so first I'm going to I'm going to call for the left side, like give me your data, and I'm going to call for the right side, that I will ask for the right data. Okay, so now I am having these two data, and now I have to update for myself. So this is actually the abstraction. Okay, first I'm going to calculate for the left side, then I'm going to call for the right side, and then with the help of these two things I'm going to calculate my side. Okay, that is my diameter and the height, and this diameter is actually the answer, because in this case we are having our maximum diameter. Okay, so this will be our answer. So for each and every node we have to return the diameter, we have to store the diameter as well as the height, and we are going to store the maximum diameter of each node. So let's do this. Okay, so first I'm going to find out the left data, that is int arr left data, that will actually the array, calculate dia and height for node, for node, let me write for node, for node. Okay, so node dot left. Now I'm going to calculate for the right side, node of right, and the right data will. Okay, so now what we have calculated this data as well as this data. Now we have to calculate my dia as well as my height. Okay, so this is actually what, this is not my diameter, this is actually the maximum diameter. Suppose, let me give you this example. Suppose there is some more nodes, that is 10, 11, 12, 13, 14, 15. So what is the diameter which is stored here? So the maximum diameter is actually equal to 1, 2, 3, 4, 5, 6, 7, 8. There the diameter is 8. And what is the maximum diameter? Diameter is actually 8. And if you calculate what is the diameter for this node, so the maximum diameter is actually the answer 1, 2, 3, 4, 5, 6, 7, 8. It is also equal to 8. So let me increase one more node, that is 16. 1, 2, 3, 4, 5, 6, 7, 8, 9. Okay, so we are going to store 9 over here, and 9 is also equal for second node also the diameter is equal to 9. Now let's calculate for this node 1, 2, 3, 4, 5, 6, 7, 8. So my dia is actually equal to the 8. So but what we have to store here? We have to store the maximum diameter for the maximum possible diameter, which is actually equal to 9. So we have to store 9 over it, not 8. Okay, so we don't have to store my dia over it. We have to store the overall maximum diameter. Okay, so that will be the answer of our binary tree. Okay, so now let's go over the code. So how to calculate my dia? So first I'm going to calculate my diameter. So that is actually equal to the left height plus right height plus 2. So how to calculate left height? That is, I'm going to take it from this left data of 1. Okay, so in zeroth index we have stored dia, and in 1th index we have stored height. Okay, so I'm going to calculate the left height plus right height, it is right data of 1, and I'm going to add plus 2. Okay, so now from this line we have calculated my diameter. Okay, what is the possible diameter from my node? Now I have to calculate the final diameter, that is the maximum diameter. Okay, so how to calculate the maximum diameter? And you can take the maximum diameter. Okay, this is what we are going to store. What is the maximum diameter? Maximum diameter is actually equal to the max of left diameter, max of right diameter, and the my diameter. Okay, so all the maximum diameter of these three is the final diameter, or you can say maximum diameter. So I'm going to take the max of all these three. Math dot max of math dot max of left dia, that is can be find out from left of 0 comma right of 0 and final my dia. Okay, the maximum of all these three is the final diameter. So now we have calculated the diameter. Now we have to calculate the height also. Okay, so height, how can we calculate the height? Height is actually the maximum of all left height as well as right height plus 1. So and height is equal to the math dot max of left height. Left height is left data of 1 comma right data of 1 and in the end plus 1. Okay, so we have calculated the height as well as diameter. Now we simply have to return it. Okay, so I'm have to new int, and now I'm going to store it and return it. So you have to put max dia, and you also have to put the height. Okay, and you have to return it. Now you simply have to call this root. Okay, so in this you will receive one array, okay, of the array of the root element. So in 0th index we are having the diameter, so I have to fetch the 0th index and simply return it. Now I hope there is printed. Okay, so now let's run this. You have to check whether for the compile time errors. So there is no compile time errors. So now our code is finished. So this is what the efficient way of doing of calculating the diameter of a binary tree. Okay, so let's see it. Let's quick see the how we have done this. So this is actually the final code. Okay, so now we are calculating the uh, diameter as well as the height for each and every node. Okay, so see, when you are traveling to the left side, so first you have called for the left. Now you want for the left data, again it is going to call for the left side. Again it, now we are in a base condition. Okay, so this is going to return the code that is 0 diameter minus 1 height. It is also going to return 0 comma minus 1. Okay, so now we have to calculate for this node. So the max, we have to calculate first my diameter. What is my diameter? My diameter is actually equal to the 0 of 1 1 minus 1 plus minus 1 plus 2, that is equal to 0. Okay, so my diameter will equal to 0. Now we have to take the maximum of all these three. Okay, so we have to take the maximum of all these three for calculating the maximum diameter. So the maximum of all these three is only equal to 0 only. So diameter is equal to 0. And what is actually height? Height is equal to the minus 1. Max will be the minus 1 plus 1, that is height is equal to 0 only. Okay, so 0 comma 0 is going to return from leaf node. Okay, so we have calculated from here. Let me erase this. Let me erase this first. Okay, so now we have written this. Now again, it is going to calculate for the right side. Okay, so how we have to calculate from the right side? Again, for this case, we have already calculated that it will come 0 minus 1. Now we have to calculate for this because first it is going for the left side as well as for the right side. Okay, so how can we calculate this? What is the diameter? So diameter is actually equal to 0, and what is the height? Minus 1. So sorry, the height is actually equal to 0. Okay, again for this case also the height is 0 and 0. So now we have to calculate for this node. So how can we do this? So we have already got the left data as well as right data. We already have these two data. Now we have to calculate my diameter by using these two data. What is my diameter? See, what is the my diameter? My diameter is left of 1, that is 0 plus 0 plus 2. My diameter is actually equal to 2. Okay, so we have calculated my diameter. Now we have to calculate the maximum diameter. Now what is the maximum diameter? Maximum diameter is actually equal to 0 0 and 2. My diameter, maximum diameter is actually equal to 2 only. Let me erase this. So now we have calculated the diameter, that is equal to 2. Now we have to calculate the height. So height is equal to 0 of 0 plus 1. Height is equal to 1. Now in this case, when we are in here, so we have calculated, we already have these two data. Okay, so in the last method, what we were doing is we were calculating height, the left height as well as the right height each and every time for each and every node. But in this case, we are just simply returning these two data. So we are not calculating the height each and every node. Okay, so we are not doing that. We are simply returning one array and we are directly fetching the data, fetching this height from this array. Okay, from the 1th index. So this is how we are saving our time. So for each node we are having one array. Okay, so when we are in a root node, so it is going to retrieve from this array and it is going to calculate the maximum diameter for the root node. Okay, so this is how our code is flowing. So let's go to the screen and let me check for all the test cases. So let's check for all the test cases, and they are running absolutely fine. So guys, thank you for watching this video, and we'll meet in the next video.